Okay, this is lesson 3.2, which is graphing linear parent functions. And so actually where I want to start is right here and tell you a little bit about parent functions. So just like in families, you get your characteristics from your parents. So the parent function possesses the basic traits of a particular type of family. So in this case, the parent function here is a linear equation. Then this is the equation y equals x. So every linear equation is going to look something like this. It's going to be very similar to this, have the same shape, but it's going to be somewhere else or be a little bit different. This is a quadratic, which is y equals x squared. And again, any quadratic function has this basic shape. It's just maybe it's skinnier or maybe it's down here or over here. But this is the parent function. Absolute value is y equals the absolute value of x, like that. And so every absolute value graph is going to have this same basic shape, just different characteristics. Then there's the square root function. These are ones that we are not going to do this year, but that's y equals the square root of x. A cubic is y equals x cubed. And then a sine graph, it looks something like this. It's called a sinusoidal graph. And that's something a little different, but that's y equals sine x. You won't do that till pre-calculus. And so today we're going to focus on the linear parent function. And so our big question as we do this investigation is, how do different values transform the parent function? So just like in transformers, to transform means to change. So how do different values change the parent function? The parent function looks like this. It goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, right? And so what I'm going to quickly do is I'm going to draw this same parent function on all of these graphs very lightly so that I can continue to ask myself, how is the new equation that I'm graphing, how is it different from the parent function, so that I can think about how that specific number changes it. Do this really quickly. Okay. So this is the linear parent function in green. All right. So let's go ahead and get started. We're going to start over here. And so first let's answer this before we start graphing anything. What's different about the linear parent equation and the equation above? So taking a look at this linear parent equation, how is this equation different from these equations? Well, this is y equals x, and this is y equals x plus 1. This is y equals x minus 1, plus 5, minus 5. So it seems like what's different is that we're adding or subtracting a value or a constant to the parent function. So what's different? We are adding or subtracting a number. And that number very specifically is a constant. Okay, so let's go ahead and take our scratch paper. And we're going to go ahead and I'm going to do these two first, and then we'll do the next two after. So y equals x plus 1, so y equals x plus 1. What I'm going to do is I'm going to substitute in these x values in for x to solve for the y values. So I'm going to substitute in x equals negative 1, so y equals negative 1 plus 1. And then I'm going to simplify. Y equals 0. So when x equals negative 1, y equals 0. Next, y equals 0, or sorry, x equals 0, so y equals 0 plus 1, which is 1. Y equals x, which is 1 plus 1, which is 2. And lastly, y equals 2 plus 1, which is 3. So now I'm going to go ahead and graph these points. This table is actually a bunch of coordinates. So this is the coordinate negative 1, 0. So I start at the origin. I move left 1 point and up or down 0. Here, 0, 1. So I start at the origin. I stay there, and then I move up 1. This is 1, 2, so I start at the origin. I'm going to move right 1 unit, then up 2. And then this is 2, 3, so I'm going to start at the origin, move right 2 units, and up 3. So what I'm trying to recognize is that what it seems like is that the parent function, it seemed to have moved, everything moved up 1 unit. So let's see if this, I'm going to make a conjecture that everything's going to move down 1 unit here. So let's go ahead and do this one quickly. X minus 1, so I'm going to substitute in 1, which is negative 2. I'm going to substitute in 0, which is negative 1. Substitute in 1, which is 0. Substitute in 2, which is 1. Now I'll go and graph these points. Again, these are all ordered pairs. So negative 1, negative 2, 0, negative 1, 1, 0, 2, 1. And as you can see, this also, everything was moved down 1 unit. So this moved things down 1. This moved things up 1. Okay, let's try these two. All right, so y equals x plus 5. I'm going to make a conjecture that this is going to move this graph up 5 units. Quickly, let's substitute in. That's 4. That's 5. That's 6. And that's 7. Okay, so let's graph it. Negative 1, 4. 0, 5. And then it goes off my paper. But that's okay, I can still graph a line. And my conjecture appears to be right, that it was moved up 5 units. So this was moved up 5 units. Okay, last one for this one. X minus 5. Again, my conjecture is that it's going to move down 5. So I actually think that my graph is going to look like 5 units down, 5 units down. I think my graph is going to look like this. And then let's go ahead and check. Y equals x minus 5. Substitute in. So then this will be, just to check, negative 1, negative 6, 0, negative 5, 1, negative 4, 2, negative 3. So look at that. It was actually the same. So what is different about the linear parent function? So these green lines and all of these graphs above, they were moved up or down. And so we need to describe the transformation for the parent equation of y equals x minus 9. So if it's minus 9, then I think that it's going to go down 9 units. So some major takeaways from what we just did. When we're using slope-intercept form, right, y equals mx plus b, again, our parent function is y equals x, so there's an m and a b that we're dealing with. So anytime that we're adding something to the ender using the constant, it's going to move our parent function up or down. So if b is positive, then our parent function moves up. If our b is negative, then our parent function moves down. Okay, so now let's take a look at the coefficients. All right, so here, what is the difference about the linear parent equation and the equation above? So what's the difference between the parent equation and these equations? So between y equals x and y equals 2x, there's this 2, 4, right, 1/2 and 1/4. So what that is there's a number multiplied by our variable. So there's a number multiplied by the variable. And that's actually what we call the coefficient. So there is a coefficient of x. So my question now is, how does this coefficient affect where the graph is? So let's grab our scratch paper again. I'm going to show you how to do the first two, and then I'm just going to graph the second two. So y equals 2x. So we have when x equals 1, so I'm going to go ahead and substitute -1 in for x, and we get y equals -2. So when y equals 0, x equals 0, y will equal 0 as well. Y equals 2 times 1, which is 2, and then y equals 2, substitute in 2, and you get 4. So our graph becomes -1, -2, 0, 0, 1, 2, and 2, 4. So our graph has shifted, it's transformed, and as you've noticed, our parent function was going this way, and now our parent function is going that way. So it's like rotated. Let's take a look at this one down here. Y equals 1/2 x. So we're going to substitute in, I actually changed these in class to -2, 2, and 4. So let's substitute in -2. So y equals 1/2 times -2. When you multiply fractions, you want to put the other number over 1 so you can multiply straight across. That becomes -2 straight across over 2, which is -1. Then y equals 1/2 times 0, and anything times 0 is 0. Y equals 1/2 times 2. Put 2 over 1, multiply straight across. Y equals 1/2 times 4. Put 4 over 1, multiply straight across. So then to graph this, -2, -1, 0, 0, 2, 1, and 4, 2. So what you might notice is it's still rotating around the 0, but it's gotten like flatter, right? It was like this, now it's like this. This one was like this, and now it's like that. Okay, so I'm going to actually just quickly graph this one. Y equals 4x would look like this, and y equals 1/4 x would look like this. And so what do you notice that's happening, right? How is this 2 affecting the graph? Well, if you notice, it's getting steeper, right? It's getting closer and closer to the y-axis, which is making it steeper, whereas when it's 1/2, it's actually getting flatter. It's moving closer to the x-axis. So what's the difference about the linear parent graph and the graphs above? The graph gets steeper or more flat. Okay, so describe the transformation from the parent equation to the equation y equals 7x. So what does this 7 do? It's similar to what the 2 and the 4 do, right? 2 got close to the x-axis or the y-axis. 4 got even closer. So I think what's going to happen is the graph will get narrower, or sorry, will get more steep. Okay? So to summarize this, that was dealing with the m, which is the coefficient of the x. And as you notice here, when we have a whole number or a number that's greater than 1, it gets steeper and steeper and steeper. Right? So we have a number that's greater than 1, like 2, 3, 4. Then the graph, the parent function, gets steeper. If we have a number that's less than 1, for example, 1/2, 1/4, 1/8, then the parent function gets flatter, gets more flat. Okay? Continue to work on this throughout the unit.